You guys ready?
I'm ready.
Totes.
Okay.
Totes my goats.
Hi, and welcome to EEs Talk Tech. My name is Daniel Bogdanoff, and we are back with longtime EEs Talk Tech alumni, Brig AC. And you probably know Melissa. Do you go by Melissa or Mel now?
I don't know. I think in the office I'm known as Mel. I think publicly Melissa. I'm okay with either, though.
Okay, cool. So eat your heart out, comments.
It's an honor to be back, by the way.
We're not talking about you, Brig. No, so you probably know Mel from the Keysight Labs channel. I think roles may have changed a little bit since last time people were on, or whatever. So what are you guys up to these days? What do you do?
Since it's about Mel, not me, so.
Yeah, it's all about me right now, so I'll go first. I'm a product marketer in Keysight Global Marketing. So I just launched, or I should say I was part of the launch for the UXR series oscilloscopes. That's what I do.
Okay, Brig.
And I manage the strategic planning for Keysight, so.
It sounds so fancy.
It sounds fancy.
Yeah, you just used to be the scope guy.
I was the scope guy, and now I'm the scope Bert and a lot of other digital products guy.
Cool. So, the podcast listeners or viewers have gotten to see your meteoric rise to strategic planning.
That's right.
So, as Mel said, normally we bring on someone and talk about a technology or a trend in the industry. Just this week, as of recording, so last week if you're listening to it as it's published, we announced the new UXR oscilloscope, and it got so much buzz on the internet, and there were so many questions. I thought we would just sit down and talk about the UXR for a moment. It's a oscilloscope that goes from 13 gigahertz up to 110 gigahertz on 4 channels simultaneously, which is absolutely insane. So I pulled a couple comments. People wanted to measure their flux capacitor and stuff like that. Just from the YouTube comments of the launch video. This is majestic. What else? I thought I had some. Oh, the Bugatti Veyron of scopes. One scope to rule them all. Wow. Keysight drops the proverbial mic with this one. This is from Mike Oliver on YouTube. This is truly a beautiful piece of equipment. It is more a piece of artwork than any other equipment I've ever seen. And I think that really sums it up, because this is just an insane piece, an insane oscilloscope.
It really is. I mean, the amount of custom ASICs that we built for this with our indium phosphide process is just amazing. Every time I sit down with one of our R&D engineers, I'm just blown away by what they actually did. So it's really amazing. The feedback that we've gotten on YouTube and things has been really exciting, and I'm so glad these engineers are finally seeing the response to all their hard work. It's very cool. Yeah,
we've just been so excited in the office this week. I think I've not seen Melissa so happy in quite a while. So one of the questions or comments mentioned, and I'm doing this a little differently. We put out a call on Twitter, on our YouTube channel, and some on the community channel of our YouTube channel, hey, ask us questions. Also on the EEV blog forum, what questions do you have? So we got some questions. One of them mentioned, this must have been really hard to keep quiet this long. So can you speak to that? I know you've both been involved in that, and that's been a bit of a struggle.
Well, I think actually the 110 gigahertz model has been the world's worst kept secret. Brig actually announced it to the public in 2016?
Yeah, we did a thing on the technology back in 2016. At that point, we thought it was a 2017 product.
Yeah.
But you think about it there was a video that actually was out there that actually had the UXR making measurements, and that came out sometime in early summer.
Oh, really?
There was a trade show, OFC, back in March, and in OFC there were a couple papers that some customers had access to the hardware early, and they inside of their papers had the UXR with its measurements. Okay. And so, there's certain parts that we definitely have done a good job of keeping secret, but the product itself, we weren't perfect on it by any stretch of the imagination.
Yeah.
And I think a product like this, a scope like this, you don't necessarily want to just keep quiet to the world until you're actively building it and shipping it. You work with key customers and key people who need this technology, because we're not just hey, let's see how fast we can go and ship out a scope. Like there's actual applications for this and people that we're talking to ahead of time. So who you don't have to name names unless that's fine. I don't know what sort of paperwork we have. But what are people doing with 110 gigahertz on multiple channels?
One of the applications is coherent modulation. So some customers are using optical communications to send information from this side of the world to the next side of the world. And it's really amazing what they're doing. So this one lab, they have a laser that creates, it creates a 193 terahertz sine wave. And then
193 terahertz sine wave.
Yes, 193 terahertz sine waves. So I think that's in the infrared spectrum.
Sure.
Yeah. And then they modulate that at 100 gigahertz. And so they're phase shifting this sine wave to create 4 different characters that their receiver can then recognize. So that's an amazing application.
That's pretty crazy.
Yeah.
Yeah, and I think the other part of that is 100 gigahertz. But one of the advantages of the scope is you have really wide bandwidth. And obviously with 110 gigahertz, that's pretty wide.
Right.
But you think about like some other instruments that are out there, they have the bandwidth, but the bandwidth you can actually look at is fairly narrow. But as you look into some of the RF technologies, 5G, wireless LAN, even some of the satellite communication, what happens is the instrumentation that's out there is somewhat limited in how big of a spectrum that it can look at. With the UXR, because you do have that 110 gigahertz of bandwidth, to look at 5 gigahertz at 80 gigahertz, right? So looking at something from 77 to 82, no problem on the UXR. And so all of a sudden now people are looking at this for 5G communications, for wireless LAN, for satellite communications, for radar, automotive radar, even like pulse radar. There's just a bunch of different communications or a bunch of different technologies right now that are being looked at.
Okay. Yeah, someone commented on YouTube, I think it was on the Signal Path, or Sharir did a teardown of this. So if you haven't seen that, go check it out.
It's amazing.
He did a really good job.
Yeah.
You know, this is jam, right?
Yeah.
So we were really excited to be able to get him one ahead of time and do that. So I pulled a comment up of that video. Someone's Mother June is commented on that video. One day spectrum analyzers will be obsolete. Oscilloscopes will evolve to have multimeter spectrum analyzers, vector analyzers or network analyzers, and logic analyzers. They exist today, but I can see 100 plus gigahertz models. Do you think, like, is this a spectrum analyzer or signal analyzer killer, or is something like this, you know, what's the future of the test measurement world look like if this type of product can exist?
So I don't think this is a spectrum analyzer killer because there's still a spectrum analyzer is still very good at very specific tasks. And when you're looking at like signal noise ratio, right? This one has a signal noise ratio in the 40s, but there's technologies out there that need signal noise ratios in the 80s and 100s, right? And so you're still an order of magnitude away from being able to really make those kind of measurements with the scope. So anyway, I don't think it's a spectrum analyzer killer, but what it does do is it augments the spectrum analyzer to where the spectrum analyzer kind of runs out of steam. All of a sudden you have an instrument with the signal integrity good enough to be able to go and make the measurements that spec an can't make anymore. And so I look at it as a spectrum analyzer augmenter.
So you should buy both, is what you're saying.
That's what I'm saying.
Yeah.
A UXA and a UXR.
Right. The other thing that really
good luck.
The other thing that kind of makes it tough is the price. It's a little bit more expensive than what a spectrum analyzer is, and so you have that.
It's a hard So Sharir mentioned a price on his video that was, you know, ballpark correct-ish for a high-end, but 2-channel. I know that that's not the official price on it. There are a few comments on price, so I'm just going to read a couple. I know we're not saying officially, you know, prices are always changing on super high-end stuff like this, and it depends on what region you live in and all that, because there's currency exchanges and all that. Someone says, that price, this is SAI Peregrine?
What were you reading?
Anyway, it says that. Sorry. See this whole page of questions we got? Just, read my mind. It says that price, it costs less than half the price of a condo in Brooklyn, New York. So You could buy 2 of these. Search on Zillow, sort price by high to low. Page 20 has a few for $2.7 million, several of which are just 1 bedroom. So, it's not a 1-bedroom apartment in Brooklyn. Let's go with that.
I heard a story about that. Like, it was funny. There's a guy in the Bay Area, right? Mm-hmm. And he says, "Yeah, I've been working in the industry for 20 years or however long." And he goes, "When I first started, scopes were $50,000. And that's how much my house would have cost." Then the next generation came around, and all of a sudden the scopes were $150,000, and that's how much my house would have cost. Now, the next one came out, and it was $500,000, and it turns out that's how much my house would have cost. By the way, he's in a really small house. And then we showed him this one. He's like, "Yeah, just worked right around with where my house price is." And so it's basically, as you look at the pricing of housing in San Jose, that's kind of tracking with the pricing of what scopes are doing.
Interesting.
This is why my generation can't ever afford a house.
Right. When did you? No, just kidding. So, somewhat glitch on YouTube. Can you make a budget version for $99? And I know the answer is obviously no, but what would be like the cheapest accessory you could add on to this?
Ooh.
So I recently saw a video on YouTube. Someone got like a McLaren or something, and they added all these like fuzzy steering wheel mods and stuff, and took it to a car show. So if you were to do that with an oscilloscope, what would the cheapest add-on be?
Well, if we're talking about like the 110 gigahertz model, there's I think there's like a 6-inch cable that you can get, a 1mm cable for like $30,000 or something.
Oh, good. Okay.
You can get like the at the 1mm, you can get a connector saver for like only $5,000.
Yeah.
There you go.
So
okay, so let's talk 1mm because we're throwing out some insane numbers for a connector right now. So let's kind of take a step back. It uses a 1mm connector. Why?
Primarily because you can't transmit, you can't get bandwidth that large unless you go down to 1mm technology. There's reflections in the channel when you use a 3.5 or 1.85 millimeter connector.
Yeah, so we're pretty much forced into the 1 mil just because of the frequency.
Yeah. However, we did 1mm connectors are so delicate and can be damaged so easily. They're also very expensive. So one of the things that we designed custom was a ruggedized 1mm connector.
Okay.
Yeah.
And does it? I know, like for network analyzers, they'll put a male connector on the output, and then you can put a female to female connector on it, and that just saves your input, so you're not like constantly connecting and disconnecting from your equipment and eventually have to break that and replace it. Is that something you could do with this? Is that?
Absolutely. So we actually include some connector savers with the oscilloscope so that you don't have to damage your oscilloscope, which would be very expensive to repair. You can instead just damage a little connector.
Yeah, which is much cheaper to repair.
We're just all about saving everybody money here.
Yes.
That's all we're trying to do.
Okay. There's a ton of questions around, what sort of size of team and what sort of time investment goes into a product like this. There are tons of custom chips. It's obviously custom from the ground up. So can you speak a little bit from like conception to delivery, what that kind of looks like and what teams are involved? And
yeah, so I'll speak to that, and then you can, Melissa, if there's more to add, then please do. So we actually started conversations on what the scope was going to look like in 2010. That's when we started thinking about like the data catcher, like what that technology should look like, what the preamp should look like, and the architecture to go around the front end. So think about it as, 2010 is when the discussion happened. And then it takes a long time by the time you start with the chips, you bring them through the pipeline, and then you actually have working products all the way through. So from conception to here, it was about 8 years, and this is 8.
Yes.
Now, one of the things we did differently, normally on scopes, you'll do the front end. In other words, you'll do like the preamplifier and some of the chips at the beginning, and then you leave your back end where your ADC is and those technologies, you leave them from the previous generation. So you're kind of stepping technologies, right? So front, back. With this one, it was a complete overhaul of both the front end and the back end. And so it took much longer to actually get through the whole process because it was a complete overhaul of the technology. As far as team size, It was big. So Keysight has a whole group of designers that just look at chips. And so we had a whole team that was focused on the chips. We had a whole team focused on the acquisition boards and the software and everything else. So this was a very large product, especially for test and measurement standards.
I think we've had a couple of the chip people on. I know off the top of my head, we had Mike Byers on who talked about ADCs with us for a while.
Yep.
You know, he was part of the planning that made this happen. So definitely just the chips alone are a pretty big undertaking.
Absolutely.
Are we talking... probably hundreds of people have worked on this product over the last 8 years.
Yeah, I bet I would be willing to bet that well over 100 people have touched this product in one way or another.
Yeah,
for sure.
That's crazy. 8 years of work all coming out. Kind of a cheeky question from Mike's Electric Stuff. We all love Mike's Electric Stuff. He's not a big fan of the black rebrand. So his question was, can I get it in beige?
I don't think they come in custom colors, unfortunately.
You don't think they come in custom colors? I was hoping that, like, if, you really... Mike, if you want to buy one, we'll probably... I'll spray paint it beige for you.
Oh, there we go. We could always spray paint. I just don't know if the plastic itself comes in beige.
We could probably CNC mill a giant block of steel out and, like, powder coat it or something.
Can you ask Mike if he wants the stripe at the top or not?
Ooh, the
that
racing
matters.
stripe.
Yeah, that definitely matters.
Yeah.
Keysight racing stripe.
Another kind of silly question, Yagiya, I think I'm pronouncing that right. Does it support zone triggering?
So,
absolutely.
Yeah, it does.
It does. Because
Yes.
all Infinium scopes also support zone triggering. I know.
Yeah. So all the Infinium software that works on your previous oscilloscopes will work on the UXR.
Cool.
What's actually nice from the software triggering side too is it has 256 gigasamples per second. So like when you're looking at pulse width and things like that with a software trigger, the limit is really your sample rate because you only have so many samples that you can go and trigger. With this one now going from 160 gigasamples to 256 giga, all of a sudden now you can look at, pulse widths that are narrower. And so your software-based triggering actually works better because of the higher sample rate.
Interesting. That makes sense. I'm trying to still process what that implications of that. So does the trigger system, obviously it needs more than 2 samples or 4 samples to do a pulse width measurement. Does that architecture massage that data as it comes in, or is it using raw sample rate, raw data out of the ADC, or what does that look like?
Yeah, so I mean, it'll basically just edge trigger, and then at that point, it just has raw data and it's just scanning. It's called InfiniScan for a reason because it's just scanning through all that. And if it sees that, it triggers on it through the software. But it has no idea other than it's just a bunch of dots, right? Sure. I mean, that it's looking at, and it just says, there's our dots that we need, and so that's how it works.
Okay, cool. A couple questions on the clock. The clocking system, how to get that accurate. So let me see if I can find those questions because I just had it out, and I should use smaller font next time. So I'm learning because I can just have one page. Here's a question. Bravo V. Is there any export regulation or restriction for certain countries? I know there's a lot of government oversight into even for some of our other equipment, what can go where. Is that a thing? Is that not a thing? Who decides that?
I think the government decides that. Yeah.
So it's kind of just handed to us, and we say,
and then we have to abide by the law.
Okay.
So if you look, there's a weird 59 gigahertz model in and so everybody goes, why'd you make a 59 gig instead of 60 gigahertz, right?
Right.
Basically because China can't take a 60 gigahertz scope with the signal integrity that this scope has at 60 gigahertz. It's restricted. Hence, we know we can do a 59, and so that's why you see a 59 gigahertz model.
Okay. Interesting. Okay, here's a question. Saba Saipos, I think on YouTube, Shreer's video. I'd be interested to know what's the timing source used in this instrument. And a couple of people replied candles or a platypus's heartbeat were the suggestions. So how do you get an accurate clock at this kind of system clock?
We use a very accurate crystal oscillator.
Okay, so it's got to have an oven and all kinds of stuff to... Okay, what's the warm-up period on that? I don't know if that's a bad question to ask.
I don't know. I know that if you're using our calibration module to do your NIST calibration. I think we recommend 30 minutes before you do that, but honestly, I've just plugged it in and done it and it seemed fine.
I think it all
Probably
depends.
not NIST traceable at that point. But.
Well,
It all depends on the level of accuracy you want. I mean, if you're just looking at ones and zeros and you just want to see if something toggling,
yeah.
then it's pretty quick.
Yeah.
Turn it on.
Sure. Okay.
If you're looking down to femtoseconds of jitter, then yeah, you're gonna want it to warm up.
Yeah.
Can I ask how long does it take to boot? I don't even know.
Not very long at all.
No.
Okay,
Yeah.
it's kind of standard Windows box.
Yeah.
This was from Nitila on the EEV blog forum. We've chatted with him a little bit online. It says, always the interesting question when creating something truly state-of-the-art. When creating a truly state-of-the-art measurement instrument, how do you measure the best instrument? Do you use indirect measurement methods or use even better measurement instruments that are developed solely for such purposes and would not be reasonable to manufacture? So obviously we don't have like secret Keysight equipment used to measure this, but how do you verify something like this? And this question came up quite a bit from other people as well.
So I think in a lot of cases we use our existing equipment. I know one time I walked back to R&D and I saw a guy with 2 S-series hooked up with our multi-scope system and was using all 8 channels to measure our acquisition system. We created the calibration module so that we could measure edges that quickly. I don't know, Greg, do you have any?
So so we also work really closely with NIST, and they have a really fast photodiode.
Okay.
And so we use that to look at frequency response. So in the data sheet, you'll see that it's calibrated to NIST standard. And so they have something that's fast enough. You mentioned secret equipment, which is kind of funny. So when we first started this, again, 8 years ago, right, when we got our first chips back, there wasn't a network analyzer in the planet that could measure at 100 plus gigahertz, right? But we just, with using the same technology, we happened to have the chips and the network analyzer that could go to 110. It just hadn't hit the broad market yet.
Interesting.
And so technically, we did use secret equipment to make the first measurements because we grabbed a network analyzer that was coming to market in 6 months or a year, whatever the time frame was, and use that to measure the 110 gigahertz.
That's pretty cool.
I didn't know that.
Yep.
That's so cool.
Awesome. And I figure if you know your source, you can just measure what's on the screen, right? Like, if I know I have a clean source coming out. Can you talk a little more about that NIST diode? Is that like a super fast edge that's well characterized, or what is?
Yeah, you can look at it as just a super fast edge. It's just a laser. But yeah, that's really what you're looking at. And what they're really doing with it is they know the characteristics of that NIST diode, and they actually measure that edge using a very fast sampling scope. Okay. And that becomes our golden reference. And then we compare that golden reference with a sampling scope that has really, really low noise against what you see with the step coming out of the UXR. And that's how you end up with this NIST calibrated. It's off against some, a calibrated reference source. And then based off that, we can compare against our measurements.
Okay, that makes sense. While we're talking calibration, let's talk about this calibrator. Because normally to get a good calibration, you have to send it off to a cal lab or someone has to bring theirs to you, which involves shipping and temperature changes and all this. So that is bad, obviously. It works, and I'm not knocking calibration systems, but to be clear, that's the best situation we have. But now we have this calibrator module. Can you explain what that is and why it's useful?
Do you want me to?
You go ahead.
Sure. So basically it generates, so you hook it into the aux out of the oscilloscope, and it takes that square wave, makes it a really sharp rising and falling edge, and then which is, it has all the data on that signal in the pod of the calibrator, and it sends it to the oscilloscope, and so you can calibrate your oscilloscope to that edge.
Okay. Anything to add, or
I'll add this. When you're looking at 110 gigahertz,
in your eyes, yeah.
If you're a couple degrees Celsius off where it was originally calibrated at 110 gig, your frequency response of the scope is going to be different than what you think it is. And so having that calibrator just to get it beyond the 1 year cal cycle, but even in between 1 year cal cycles, being able to make sure you're within plus or minus a couple degrees Celsius all the time ensures that you get really very accurate measurements. Okay. So that's the other benefit there.
That's cool. Does it, and it's like a valid NIST, is it NIST traceable?
It is, yeah.
Interesting. Okay. That's pretty cool.
Mm-hmm.
Go NIST.
NIST, you're welcome.
Okay.
I figured it was publicity for him.
Yeah. Yes. Right. That I was like, why are they welcome? Let's talk probing. 110 gigahertz probes aren't really a thing. So what
They're called cables.
Say that again.
They're called cables.
Cables. So what does that look like for people?
Very short 1 millimeter cables.
Okay, like a couple inches, like the 6-inch thing.
Yeah.
And they know that this is going to be their measurement instrument for it, or their receiver, whatever they're using it for, and they just design that into their device, and you connect the cables. Do you have to use like a torque wrench and all that too, or is it a?
Yeah, we provide the torque wrench to kind of help from damaging the very delicate connectors.
Okay, fair enough. Someone, I didn't copy their username. Sorry, whoever asked this question, I'm doing you a disservice. According to the specs, because you can get data sheets or whatever online now, it looks like the 2-channel version Shreer looked at only requires 1370 volt amps and can run off of 120 volts. And the 4-channel version works off of 200 to 240 volts. And there's a little like face with tongue sticking out. So, something like this obviously requires a lot of power.
Yeah.
So why? And, do you have to go custom wire your lab if you want to use the 4-channel one?
Yeah.
You do.
Yeah.
Yeah. So,
Which is fine. If you're buying the scope, you can rewire your lab.
So you have to kind of think about it from an architecture standpoint of the scope.
Yeah.
So each channel, right, has 256 gigasamples per second in it. So what does that mean?
What's the data rate on that then?
You're 10 bits, right?
Yeah. Oh.
So you're running 10 bits. So literally, when you look at the whole system, right, you're running 10 terabits per second through the whole system. When you consider the 10 bits and the 256 gigasamples per second and all the math, right? And so to do 10 terabits of data through the whole scope, you need ADCs, you need the data catcher, you need all the memory, you have the preamp, all of that takes a bunch of power. And so anyway, it all comes down to being able to push that much data through at that speed. And at the end of the day, you end up with, an emoji with the tongue sticking out going, that's what you end up with. I mean, there's no way around it.
Right.
And that's why you have to build something in your lab that allows for you to do that.
Okay.
And I don't know if you mentioned this, but since we do that on each dedicated channel, there's an acquisition board for each channel. So once you double the amount of acquisition boards you have, that increases the power. And so that's why 2-channel runs off of your standard power outlet, whereas 4-channel, you have to get the special 220 volt.
Okay. Someone mentioned, and I'm trying to find it on my page again, 10-bit ADC instead of 8, and the whole system is running on a 10-bit architecture. Can you speak to that a little bit and the benefits or why we chose that?
Go ahead, Melissa.
Okay. So 10-bit ADC gives you 4 times the resolution of an 8-bit ADC. So really, you're getting so much better resolution with a 10-bit ADC. I don't know.
Okay.
Yeah.
So here's a question.
4 times better.
The question came in on our YouTube channel, which I just have on my phone right now.
Were you bored with our conversation and we're looking at YouTube while we're talking? Is that what just happened?
You're watching cat videos over there.
I pre-pulled this up just because I realized I didn't print it off. Although Shreer did post a picture on Twitter of his cat reaching new heights.
So cute.
It's great.
Oh my
Check it
gosh.
out. This is Shahid Khan on our community YouTube channel. Tell 110, does it matter? I'm going to try and rephrase this a little bit. 10-bit, so essentially the question is, why not a higher resolution ADC? So why 10 bits instead of, obviously, like you're saying, you get more resolution with 10. Why not 30?
So, number one, there's no 30-bit ADCs out there on the planet.
But we make our own, right? Tell the ADC team to make it 30 bits.
They ought to.
Why not?
Ultimately, the problem is the ADCs have to have a certain amount of bandwidth to them. So you can't just say, hey, I'm going to do a 30-bit ADC, because then you got to consider how much bandwidth, how much sample rate, and everything else that's out there. And that's one of the things with ADCs. There's a lot of trade-off on, bits of resolution versus sample rate versus versus the actual bandwidth of the ADC. And right now, to do a 30-bit ADC at 110 gigahertz, the technology is just not there.
Okay. Cool.
It's a good idea, though. We'll mark it as a strategic planner. We'll mark it in there and make sure to add it in our future.
For you, Shahid, it's coming.
It's coming
Someday.
Someday. It's right there, right on the roadmap right now for you.
So if you had a 30-bit ADC, how much better would the resolution be than an 8-bit?
Well, so it'd be way better.
Clearly.
22 bits.
What you got to
22.
What you got to understand on these things, if the difference between like a 10-bit and a 30-bit ADC, when you're dealing with 110 gigahertz, at that point, your ADC resolution doesn't buy you very much because the preamplifier of the scope with all the noise and everything that it has is going to drown out any of the extra bits of resolution that 30-bit ADC goes. So hopefully by the time we get to a 30-bit ADC, our preamp's, 10,000 times better as well. And so we get benefit. So essentially, I think the difference between, a 10-bit ADC and a 30-bit ADC, if you use the same front end, I'm not saying it's zero, but it's pretty close.
Probably not worth the R&D effort.
It's not.
Or you don't get valued.
But it doesn't mean we're discounting your idea out there. It's there. It's right in there on the list of enhancements.
Okay. Also, does it go down to DC or is there a minimum frequency input?
It does go down to DC. So when we say 13 to 110 gigahertz, we don't mean that it can only measure down to 13 gigahertz. We mean that the base model starts from 0 gigahertz up to 13 gigahertz.
So all the way down to DC. Let's talk frequency interleaving, because that's a common technique.
Yes. So that's one of the coolest things about this oscilloscope is that we are able to get away from frequency interleaving. In the past, the hardware of oscilloscopes was actually, like the bandwidth of the oscilloscope was limited by the hardware. And so you couldn't get above 40 gigahertz without doing this thing called frequency interleaving, or I believe competitors might call it ATI.
Digital bandwidth interleaving.
Yes.
Yep. Hybrid filter bank.
Yeah. So what we've done is we've designed hardware that actually has 110 gigahertz of bandwidth so that we don't have to then, take a high bandwidth signal, split it into 2 different sets or even 3 different sets if you're trying to triple the bandwidth of your hardware. And then, in frequency interleaving, you then have to stitch all those components back together before you even get to the preamplifier. So when you do that, you're mixing in all this noise to your signal, and then it gets to your preamp, and your amplifier then amplifies that noise that you just added to your signal. So now we're able to just take 110 gigahertz signal straight into the oscilloscope, send it all the way down to our samplers without doing any interleaving at that point.
Cool.
Yeah.
Yeah. So not having to do that really helps the noise
Absolutely.
a ton.
Yeah.
So a lot of this is indium phosphide, right?
Yes.
Yes. Why that, and how do you build it and all that? Tell me about that, I think is what I'm trying to say.
So indium phosphide, one of the main reasons is it's a material that goes really fast. We actually, from Keysight perspective, have a fab that does indium phosphide. And so a lot of our high-end instrumentation is done off of indium phosphide. And so it's something that Keysight invested in probably 15 years ago. They started to look at indium phosphide before they were gallium arsenide based. And so, it turns out it provides really fast transistor switching speeds. And we happen to have some expertise in there. So it makes a lot of sense for us to do our high-end instrumentation on indium phosphide.
Okay. Cool. Switching gears a little bit. This is from Alberto Vaudagna on YouTube.
That felt wrong.
No, Vaudagna.
No, maybe it wasn't.
Vaudagna. Might be like Italian, like Bologna.
Yeah.
Right? Vaudagna? No, I'm just going to try and do bologna out of it.
You're just digging a deeper hole.
I am. That is so true. Let's get to the question, shall we? So I know on our InfiniVision oscilloscopes, the ASIC processor, the MegaZoom ASIC, handles the plotting of the signal and all that. So this question is, do you know what happens to the data after the DSP goes to the CPU motherboard and is processed by the CPU, or is the data overlaid on screen and the GUI is run by the CPU? Does that question make sense?
It does.
Okay.
So it turns out you have a choice with our software. So similar to what you talked about with the high volume scopes, there's a fast plot mode. And in that case, basically, before really the processing really hits the CPU, we display it. And so essentially you're looking at 1 million waveforms per second, or not quite that high, 150,000 or 200,000 waveforms per second, depending what you're looking at and how deep your memory is. So in that case, you're zooming really fast. If you're looking for like a glitch or something, it's a really good concept, and you aren't buried with processing. The strange thing with that, and I'm just, as a Keysight guy, I'm telling you it's strange, is if you're making measurements, you have this waveform that's just blasting, right, and really fast, but your measurement speed isn't keeping up with that plotting, because in order for the measurement engine to go through, you have to go through the CPU. And so you can actually turn off the really fast plot to where your measurements and your waveforms hit at the same time. Does that make sense, or was that?
So you can kind of like burst capture more or less.
That's right.
And make measurements on a subset of those captures.
Yep.
Or you can switch it into like one measurement per capture mode.
Exactly. So you have a choice, and it just depends what you're doing as to which one you want. If you're looking for like glitch or something like that, it's the way to go. We were just at a customer's like 2 days ago, and they were debating whether they were having an issue on the transmitter side or the receive side. And on the transmit side, they were running the signal.
Before we get there, I'm sure the transmitter people thought it was the receiver's fault.
That's exactly right.
It was the transmitter's fault.
It was totally the receiver guy's fault, but that's a whole nother story.
Called out. Yeah.
But they were looking at real-time eyes, and they couldn't figure out if the problem in the real-time eye was related to their transmitter. And they weren't able to capture enough data fast enough to see it. Okay. With this, they were able to just turn it on. They looked at 100 million UI in about a minute, and they're like, okay, it's not on our transmitter. And so able to isolate back to the receiver, fix it, and I assume they're going to fix it.
Fair enough. I know we can't go specific. As we start to wrap up, I know we can't get specific with it. Like I said, what kind of sales volumes do you expect for 110? Like, how many people out there are buying it? Is it hundreds? Is it one? Is it dozens? Thousands? Hopefully
it's more
millions.
Than one.
Well, we know it's more than one.
It is one. Please buy the one unit.
We have the one from the video.
Exactly. It's still for sale.
It's a good number of people, though.
Yeah.
Is probably the answer I would give if I were in your shoes. Let me lob you a softball here.
So, sorry, Mel. I don't mean to. So, you can kind of think about it as, you really have 3 different scopes in one scope, or 3 different versions of the scope. Okay. And it really is kind of like a reverse slope as far as your volumes go. Yeah. So when you're down at 13 to 33 gigahertz, there's a bunch of technologies where a lot of people are. PCI Express, DDR, HDMI, DisplayPort, a lot of those typical high-speed serial buses, digital high-speed serial buses sit there. And so the volumes will be high there, right?
Right.
As you get up into the 110 gig range, you can go to like ECOC papers and say, how many people are writing these kind of papers? And those are pretty much your guys that you're going to be selling to.
That makes sense. Okay. Anything to add, Melissa, or you good?
That was perfect answer.
Okay, cool.
First one of those I've ever had. Felt good.
Briggs like, I hope my boss isn't watching this podcast.
Please don't watch the pricing podcast.
Yes. That was the last podcast we did. I was trying to remember before which one it was. It was the how to price your hardware.
I know.
That was a good one.
That was a really good one. I enjoyed it.
That was fun. Okay, last question from the internet and the interwebs that we're going to answer at least. No, we pretty much took them all. There are a lot of comments about how did it show, like Schreier got this scope and did it just like show up in the mail, or like how do you deliver armed guards?
No, we just FedEx it. We put it in a huge transit case. It is so heavy.
That was a question I missed.
And like this, it's just like a armored. I don't even know how to explain it. It is heavy duty, and then we just FedEx it.
Yeah. I think Schreier said the box was like 160 pounds when it arrived.
Yeah.
And I physically lifted these. The handles. Someone commented on the handles are like these like metal bolted in like industrial handle, and that's kind of what you have to have.
Yeah.
Yep.
Now, I really hope that's not your very last YouTube question, because I saw several comments
Bring
about
it.
communicating with aliens.
Oh, we didn't talk about we were not allowed to talk about the aliens.
Oh.
They told us we couldn't.
Oh.
No, I'm just kidding. I don't know.
Well, anyways, if you weren't joking about using this to communicate with aliens, please invite me to your lab. I would be fascinated to learn what you do. Absolutely fascinated.
In your communication with aliens, is what you're saying.
Yeah, if you're communicating with aliens, I want to know about it.
Okay.
I can keep a secret. You can trust me to keep a secret. I kept the 13 gigahertz UXR a secret for, what did we say, 8 years?
Yeah, a long time.
I was trying to think of where I was 8 years ago, and it's like, yeah, I don't want to say on air. It's like in preschool or something.
Right.
No, not really. Yeah, actually, if they're communicating with aliens, we might just give you one of these.
Yeah, I think that's a fair.
I will
fair
commit
takeaway.
Brig to that as a strategic planner.
Well,
'Cause that's a whole new world of business opportunity for you strategy guys.
absolutely no. And if you're an alien, right, you get 110 gigahertz of direct digitation of the signal. I mean,
There you go.
where else are you going to get that in this world? Nowhere. So aliens, 110 gigahertz.
Keysight, Colorado Springs,
That's
be
right.
there.
Come and join us.
Please beam down.
We are your leader. Okay. Anything else you guys want to talk about? This has been a blast.
This is a
No?
good time.
So we always end every podcast with a stupid question for our guest. Usually I stall and I kick it to Mike so that he can ask his question while I'm thinking about mine. And with Mike being out of town, I'm now stalling as I'm talking. If you were to have a personal UXR, where would you put it and what would you do with it?
Oh my goodness. Well, my first, when I wasn't making measurements with it, I would have it at the foot of my bed as a foot heater. That's definitely what I do.
Like a towel warmer for when you get out of the shower?
Absolutely.
Ooh, I like
Yeah. Be really toasty in the winter.
that. Mhm.
Great.
Yeah.
Can I say eBay?
There you go.
Yeah.
My
He's like,
generation would finally.
I'm
be able to afford a
retired.
house.
I won the lottery.
Yeah. Whew. Yeah, go dumpster diving at the Keysight office. You might find a fully functional UXR and Dave.
I tell you what, if Melissa gets one and she uses it as a foot heater, I will swap her UXR with the foot heater, and then I'll go back to eBay.
It's the best heater money can buy. That's a good plan. I'm liking this.
Yeah, clearly I wasn't thinking this through.
Okay, that is all for today. I don't know if this will be 2 episodes or 1 because we've gone kind of bonus time here. Brig, thank you so much for being on, and Melissa, thank you for both of you for all your hard work getting the UXR out the door. It's been just a massive project, like we said.
It's all been the R&D guys. I just write about it.
No, you've blood, sweat, and tears, I think, on the UXR for probably both of you guys. I saw Brig weeping in his cube the other day.
I've cried nightly for 8 years.
Okay, that's all. Thanks for watching. I'm Daniel Bogdanoff. Make sure you subscribe to the Keysight Podcast YouTube channel. Check us out on the Keysight Labs YouTube channel as well. You probably recognize Melissa from over there, so hopefully we'll get some more videos from you soon. And Brig, our somewhat off and on podcast host when we just feel like having him on.
It felt good being on again.
Yeah, it's good
I
to
missed
have
you
back.
guys.
Yeah, Briggs has been a supporter of the podcast from day one.
Yep.
Thank you to all our listeners. You can check out more at EEsTalkTech.com. Thanks for watching. If there's anything you want us to cover in the future, let us know in the comments, or you can hit me up on Twitter at Keysight_Daniel. We will see you next time.
I thought it was going to be this amazing, surreal experience, and I just felt like a sausage.
Oh, yeah.
It was brutal.
Okay.